So now we're going to do two examples of the two sample variance comparison hypothesis test. And you can see here we have a sample from population C and a sample from population D. And it says determine whether the variances of the two populations are significantly different at the 0.01 level of significance. Okay? And so we're going to go through the steps that we just learned in the previous video. And the first thing that we're going to do is we're going to identify the variance and the sample size of the sample from population C, and we're going to do the exact same thing for population D. All right, so you can see here we've entered the data for population C and the data for population D, and in both cases we're going to identify the sample variance using descriptive statistics. All right, so we can see that for population C, the sample variance is 13.866666. So let's go ahead and put that in, go ahead and write that down. So that's population C. So we're going to say that, so step one, S squared sub C is equal to 13.866666. And what is our sample size? Let's see, our count down here is 16. And so sample size is 16. And now we'll do the same thing for the variance from the sample from population D. We can scroll down here and we will see, here it is, it's 4.525641. So 4.525641, and our sample size is 13. Sample size of 13. Okay, so that's step one. In step two now, we're going to identify one of them as the numerator, df1, and the other one is the denominator, df2. And so you can see that, that the sample from population C has a larger variance, and so we're going to call this one numerator, or we can also just call it df1, but we need to know that it goes in the numerator. And then the smaller one we're going to call the denominator, or df2. Or df2. Okay. All right, so that's step two. Now let's move on to step three. We're going to state our null and alternative. So here we'll put step two is that and that. Okay. And then step three, we're going to state our null and alternative hypotheses. So H sub O is that the variance from of population C is equal to the variance from population D, but our alternative hypothesis is that the variance from population C is not equal to the variance from population D. Okay, and then in step four, we're going to identify the alpha, which is, let's see here, 0, there it is, 0.01, level of significance is 0.01. This is an F test. And then df1 is going to be the degrees of freedom from the numerator. And n is 16, so that means 16 minus 1 is 15, so df1 is 15. And then we also need df2, which is going to come from the other one, and it's 13, so 13 minus 1 is 12. All right. Step 5, now we're going to need the critical F value, which we're going to get from Excel. So we need F crit, and let's go over to Excel. All right, here we are in Excel. We're going to type in equals f.inv.rt parenthesis, and then we're going to put in the level of significance, the alpha, 0.01, comma, then the df1, let's see, what was the df1, is 15 and then 12. 15, comma, df2 is 12, and then enter, and it looks like our f value is 4.009, and then the 6. So this 6 is going to cause the 9 to go up to a 10, so it's really going to be 4.01, and we can actually do this by moving this. If we were to move this all the way over here, narrow the, it would say 4.01. There's another way to do it. Go up here to the Home tab and then click on Number. These things here will allow it to, have more numbers or more decimals or fewer. So if we do this, it actually brings it down. It's now 4.01. And so that makes our F crit 4.01. And so we're going to say reject the null hypothesis, H sub O, if our F statistic, which we'll calculate in a second, is greater than 4.01. And now we'll move on to step 6, which is to calculate the F statistic. And F is equal to, we're going to put the numerator, which is 13.8666, so 13.866666 divided by 4.525641. And now we need to go over to a calculator. All right, here's our calculator. We're going to do 13.866666 divided by 4.525641, and our F statistic is 3.064. So 3.064, and since 3.064 is not, it's not greater than 4.01, we will say do not reject, reject H sub O, okay? All right, let's do one more example. All right, so here's another example. We have population E and population F. This is a sample from population E, and this is a sample from population F. You may say, wow, that's a much bigger sample from population E than this is from population F. That's okay. They don't have to be the same. We are going to talk about sample sizes that are equal in lesson 18, but not in this one. Determine whether the variances of the two populations are significantly different at the 0.02 level of significance. Okay. All right. Well, step 1 is going to be to identify the variance and the sample size of this sample from population E and also this sample from population F. So let's go over to Excel. All right, here we are in Excel. Here's the sample from population F, and here's the sample from population E. So we're going to go to, I know I'm going to have to widen these columns so I can see the whole number. Let's go to Data, and we'll go to Data Analysis, Descriptive Statistics, and hit OK. We will get this group up here. It's going to be from here down to here. That's our input. Okay, and then our output range. Let's go ahead and put the output maybe right here. Summary statistics is what we want, so we'll hit OK, and there we go. And here's our sample variance. And now we'll do the same thing for the population, the sample from population F, descriptive statistics. We'll input range, we'll come down here, we'll grab these numbers right here. Good, and we'll make our output range, we'll put it maybe around down here. Okay, we want summary statistics, we'll hit OK, and here we go. Our sample variance is 34.944444, okay? All right, so let's bring this one over here first, 7.905797. So the variance, sample variance from population E is, let's see here, what is it? 7.905, 7.905, 797, 797. And our sample size, N, is, let's see, 24 right here, 24. And then our variance from population, from the sample, from population F, let's scroll down here, is 34.94444. So 34.94444, and our sample size is 10. So N is 10, okay? All right, in step 2, we're going to decide which one is the numerator and which one's the denominator, and the larger one is the numerator, okay? So this 34 is going to be the numerator, and we're also, along with that, sometimes we refer to it as the variance that has the degrees of freedom 1, df1. And so the other one, the smaller variance, that's going to be the denominator, and or df2, okay? And now moving on to step 3. In step 3, we're going to state our null and alternative hypotheses. And so our null hypothesis is going to be that the population variance from E is going to be equal to the population variance of F, okay? And our alternative hypothesis is that the population variance from E is different than, not equal to, the population variance of population F, okay? In step 4, we're going to state the level of significance, the alpha, which in this case is 0.02. You can see that right over here, 0.02 level of significance, 0.02, that this is going to be an F test, and that our degrees of freedom, df1, is going to come from this numerator, or df1. N is 10, 10 minus 1 is 9, so df1 is 9. Our df2 is, N is 24, 24 minus 1 is 23, and therefore df2 is 23, okay? And so now step 5, we want to identify our critical F value, F crit equals, we're going to go get that from Excel, and we're going to put in 0.02, we're going to put in 9 for df1 and 23 for df2. All right, here we are back in Excel, and we're going to type in equals f.inv.rt parenthesis, and we're going to put in the alpha, which is 0.02, comma, the degrees of freedom 1 is 9, and the degrees of freedom 2 is 23. Close parenthesis and press enter, and it looks like our critical F value is 2.866. I want to go to home, and I want to go to number, and I want to decrease the number of decimals. So, or sorry, that's increase, decrease. So if I do this, I only want 3 of them. There we go, 2.867. There's my F crit, 2.867. So go back, F crit is 2.867. So we are going to reject H sub O if the actual F statistic is greater than 2.867, okay? Now we want to calculate the F statistic, and so we're going to do F is equal to, the numerator is 34.944, 34.94444. I think that's the correct number of 4s. Yep, divided by 7.905, 797 equals, all right, let's go over to the calculator. Here's our calculator, so we're going to do 34.944444 divided by 7.905, 7.905, 797, and our it looks like our F statistic is 4.42. It would be 4.420, but this 1 we're going to knock that off. It doesn't round this, so we can just write it as 4.42. But if you wanted to write it as 4.420, you could. 4.42. And since 4.42 is greater than 2.867, then we can say reject H sub O, and that's our final. And that implies that supports the idea that the variance of E is very different than the variance of F. And that's it for this two-sample variance comparison test. Hopefully 3 examples is enough for you, and let me know if you have any questions.